everyone. Welcome to 7th grade math, integers and rational numbers, home edition. My name is Casey White. I am a 7th grade math teacher at Gresham Middle School. So first today, we are going to look at adding rational numbers. Now, before we just jump straight into adding rational numbers, we're going to talk about a little bit of review. We're going to look at some vocabulary and kind of figure out what we really need to be able to do. So in order to add rational numbers, we have to be able to look at numbers and figure out, are they positive or negative? What does that mean? We have to know what opposites are. And then we also have to understand what are rational numbers. So for a little bit of review, positive numbers are all of the numbers that are to the right of 0. So that is your normal counting numbers. 1, 7, 12, all the numbers like that. Here are a few listed as examples. Negative numbers are all of the numbers that are to the left of 0. So they're just like the positives, they're just on the other side of 0. And they have that little negative sign in front of them. So like -4, -7, -18, -95. Numbers with a negative sign in front of them. Next we have absolute value. And if you recall, absolute value is just a number's distance from 0. How far is that number located from 0? So I've listed a couple examples here. If we take the absolute value of -5, how far is -5 from 0? Well, -5 is 5 spaces from 0, so we would say that the absolute value of -5 is 5. What if we wanted to ask the absolute value of 6? Well, how many spaces away from 0 is 6? It is 6 spaces. So the absolute value of 6 is 6. Now, opposites are numbers that when placed on a number line are the exact same distance away from 0. So that's numbers like 5 and -5. They both have an absolute value of 5. So those two numbers would be called opposites. Now, when we add opposites together, they have the special relationship of adding and having a sum of 0. Those are what we call additive inverses. Now let's talk about the types of numbers we're going to be looking at. We're going to be looking at integers, which are all positive and negative whole numbers. We're also going to be looking at rational numbers, which is any number that can be written as a fraction. So that's your numbers like -1/2, 3/4, 2 1/8, 3 25/100, 2.3 repeating, any type of number that can be written as a fraction. Now, before we just launch into adding rational numbers, here's a few questions for us to ponder. What were those rules that I had to use for adding integers? If I had a problem like -2 plus -3, what would I do to add those two numbers together? Well, first I'm going to look at them and I'm going to decide, are my numbers both positive, both negative, or do I have one of each, a positive and a negative? Well, in this case, they're both negative, so I'm simply going to add their absolute values. So 2 plus 3 is 5. And since they are both negative, I'm going to keep that negative sign. Okay, so again, if the two signs are the same, I'm going to add them and keep that same sign. Well, but what about if they're not the same? What if I have 8 plus -2? Well, when you have a positive and a negative, we now have to subtract the two absolute values. So we're going to take 8 minus 2, which is 6. And then we're going to take the sign of the greater absolute value. In this case, 8 is the greater absolute value, so my answer is going to be positive 6. So if I look back over here, how do I know what sign to place in front of my answer? Well, a good rule of thumb, always take the sign of the greater absolute value number. So let's look at those rules. If the signs are the same, first rule right here, if the signs are the same, you can simply add their absolute values and keep the sign. That's problems like 8 plus 6, negative 2 plus negative 14. Problems like that. If the signs are different, so say we have 4 plus negative 8, then we have to subtract their absolute values. So I'm going to take 8 minus 4, which is 4. And then whichever number has the greater absolute value, I'm going to keep that sign. In this case, negative 8 has the greater absolute value, so my answer is going to be negative 4. Now, if those rules are still a little fuzzy with you, you may want to take a second and review those and see if you can get those to memory, because that will help us in the activity we're going to do in just a second and in the next few problems. Okay, let's look at these 3 problems of adding rational numbers. So for the first one here, 8 plus negative 2. 8 and negative 2 have different signs. One is negative, one is positive. So I'm going to subtract their absolute values. So I'm going to say 8 minus 2, which is 6. And then I'm going to ask myself, which one of these has the greater absolute value? What do you think? Is it 8 or negative 2? If you said 8, you are correct. So my answer for 8 plus negative 2 is going to be positive 6. Now let's look at a decimal problem. What do I need to remember with decimals? If you said I need to line up the decimal point, you are correct. So look at this problem. Negative 5.6 plus negative 2.43. Are their signs the same? If you said yes, you are correct. So are we going to add or subtract? Well, I hope you said we're going to add. So I am simply going to stack these two decimals. Simply going to stack these two decimals, lining up the decimals, and notice I stacked them and wrote them with their absolute values because we are going to add their absolute values. Now I do not have a number right here after the 6, so I'm going to add a placeholder 0, and then I'm just going to add straight down. 0 plus 3 is 3. 6 plus 4 is 10, so I'm going to put my 0, carry my 1. 5 plus 2 is 7, plus the one I carried is 8. Then I'm going to bring my decimals straight down. Now, go back and ask yourself, well, what's my sign? Since both of my numbers were negative, my final answer is going to be negative 8 and 3/100. Now, last one, we are going to look at one fraction problem. And I know you're probably sitting there thinking, oh, not fractions. But you can do this. So remember, when we're dealing with fractions, we have to have a common denominator. So looking at my denominators of 2 and 3, my common denominator is going to be a 6. So now I'm going to rewrite my fractions as their equivalent. So 1/2 equals 3/6. Negative 2/3 equals negative 4/6. Now I have a common denominator. I can go back and think about my rules. Are my signs the same or are they different? I hope you said they are different, so I am going to add or subtract. Which one do you think? I hope you said I'm going to subtract, so I'm going to subtract their absolute values. So 4/6 minus 3/6 is 1/6. And then the last thing that I need to do is ask myself, what sign do I need? So looking back at the problem, 3/6 plus negative 4/6, which one of those fractions has the greater absolute value? If you said 4/6, you are correct. So I'm going to take the negative sign that is with 4/6 and make my answer negative 1/6. Now, that is just a quick review of adding rational numbers. So if you need to go back and double check and review these rules again before you begin your activity 1, I would highly recommend that. And then keep these in mind as you work through that first activity. Good luck. Okay, on to activity 2, which is subtracting rational numbers. It is going to tie in very, very closely to the adding rational numbers that we just looked at. So we need to be able to understand that subtraction of rational numbers as adding the additive inverse. So yes, you heard that correctly. We are going to take each subtraction problem and change them to an addition problem. By doing that, we will show that the distance between the two rational numbers on the number line is the absolute value of their distance. So a little bit of review again is absolute value. Remember, we always have to know what absolute value is. It is the number's distance from 0. So remember, it's how far a number is located from 0. Also, remember opposites. Opposites is going to be a big word that's going to come into play for activity 2. So make sure you understand what an opposite is. It is two numbers. They are two numbers that are on opposite sides of the number line, the exact same distance away from 0 on opposite sides of the number line. So like 5 and negative 5, 2, negative 2, negative 8, positive 8. Remember, integers are all positive and negative whole numbers. And then remember, we're dealing with rational numbers, which are any number that can be written as a fraction. So remember, that is like your negative 5/10, 2/5, negative 1 1/4. Any number that can be written as a fraction. Okay, so when subtracting rational numbers, the key thing you need to remember is add the opposite. Add the opposite. And you may be thinking, well, wait a minute, didn't you say we were subtracting? Yes, but the rule for subtracting rational number is add the opposite. So we are going to take each of these subtraction problems and we're going to change them to addition problems. So let's see what that looks like. Let's look at a very simple one to start. Let's look at negative 3 minus negative 2. Now this is a subtraction problem, but we're going to use our rule add the opposite. So the way we do that is our first number always stays the same. Change your minus sign to a plus and take the second number and change it to its opposite. So what is the opposite of negative 2? If you said 2, you are correct. Now we need to know those adding rules. So let's think back to those adding rules. For negative 3 plus 2, are my signs the same or different? correct. They are different. So when my signs are different, I'm going to subtract the absolute values. So 3 minus 2 is 1. And then I'm going to take the sign of the number with the greatest absolute value. Does -3 or 2 have the greater absolute value? If you said 3, you are correct. So my final answer is going to be -1. Let's look at one more quick example problem. Let's say we have 8 minus 12. So again, we're going to look back at our rule, add the opposite. First number stays the same. Minus sign changes to a plus. Second number of 12 is going to change to its opposite. What is the opposite of 12? -12. Then I'm going to ask myself again, back to those adding rules. Are my signs the same or different? Well, I hope you said they're different. And since they are different, I am going to subtract. So absolute value of -12 is 12, minus 8 is 4. And then I'm going to take the sign of the greater absolute value. Which number has the greater absolute value? Well, I hope you said -12. If you did, you are correct. So my answer is going to be -4. Now let's take a look at subtracting rational numbers, some fractions and decimals here. So right here, let's look at example 1. The very first thing I'm going to do is apply my rule of add the opposite. So I'm going to rewrite this example 1 to -3 and 5/10. First number always stays the same. Minus sign changes to a plus. Second number changes to its opposite. What is the opposite of -2.7? 2 and 7/10. If you said positive 2 and 7/10, you are correct. Now let's think. Do I have the same signs or different signs? If you said different, you are correct. So let's subtract these two decimal numbers. Remember, we are carefully lining up the decimals. And we are going to subtract. Make sure you put your greater absolute value on top. I cannot do 5 minus 7, so I'm going to borrow from the 3 and make it a 2. 15 minus 7 is 8. 2 minus 2 is 0. Bring your decimal straight down. So my answer here, 0.8. And then the very last thing I need to do is to check my sign. So which number has the greater absolute value? -3.5 or 2 and 7/10? Well, I hope you said there that it is negative. So my final answer will be -8/10. Okay, let's look at number 2. Number 2, 6 minus 9 and 3/10. Well, first thing I'm going to do again is apply my rule of add the opposite. So first number stays the same. Plus, what is the opposite of 9 and 3/10? Well, I hope you said -9 and 3/10. Now I've got to think back to those adding rules again. Are my signs the same or different? They are different, so I'm going to do what? Well, I hope you said I'm going to subtract. So again, I'm going to stack my numbers, 9 and 3/10 minus, well, 6 doesn't have a decimal, but I know, but since it's a whole number, it's going to be 6.0. And I'm going to subtract those numbers and get 3, decimals straight down. And then I'm going to ask myself, is my answer positive or negative? Since -9 and 3/10 is the greater absolute value, my answer will be -3 and 3/10. Now we're going to attempt one last problem. And I'm going to do this fraction problem, again, a fraction, over on the side up here. So I've got 7/8 minus -1/4. And if you remember from working with fractions, we have to make sure that we have a common denominator. But before I do anything, I'm going to yet again apply my rule of add the opposite. So 7/8 plus the opposite of -1/4, which is 1/4. Now there's no negative signs at all, so I can just add these two fractions. So my common denominator is going to be an 8, 7/8 plus, we're going to make that 4, that denominator an 8. I do that by multiplying by 2, so my numerator is going to be 2. Now I can just add 7/8 plus 2/8 is 9/8. Now I'm going to convert that to a mixed number, which is 1 and 1/8. And since both of my numbers are positive, my answer will be positive. So remember, anytime you are subtracting rational numbers, add the opposite. Some guiding questions as you begin activity 2. Make sure you know that rule. Add the opposite. Make sure you remember what do I do to subtract decimals? What's so important there? And what do I need to remember about subtracting fractions? And then always make sure you're looking at your numbers and deciding if your answer will be positive or negative. Good luck on activity 2. All right, boys and girls, now let's take a look at multiplying integers. So first we're going to look at multiplication how it is extended from fractions to rational numbers by requiring that operations continue to satisfy the properties of operations, particularly the distributive property, leading to products such as -1 times -1 equals 1, and the rules for multiplying signed numbers. Again, just a little vocabulary review. We've already talked about integers and how they are all positive and negative whole numbers. Keyword there is whole numbers. And just recall for the sake of this topic that rational numbers are any numbers that can be written as a fraction. So that is your numbers like 1/2, 5 7/10, -1.3 repeating. All the numbers like that are rational numbers. But just for this part on multiplying, we are going to stick to just integers. Also, in our standard, it said that we needed to know what the distributive property is. Now, the distributive property says that if I have 3 times 2 plus 5, then I am going to distribute that 3 to both of the numbers inside the parentheses. So I get 3 times 2 plus 3 times 5. Then I can just follow the order of operations and multiply 3 times 2, which is 6, 3 times 5, which is 15, and then add those two numbers to get my answer. You'll learn much more about the distributive property later on. So multiplying integers. To multiply integers, or multiplying in general, remember that multiplying is repeated addition when the first factor is positive. When the first factor is negative, we're going to use repeated subtraction. So look at the two examples over here on the side. That is, these two are just kind of showing the patterns that we're using when we multiply. So it shows that -6 times 2 is -12. -6 times 1 equals -6. And it shows that they're going from -12 to -6. I'm adding a positive 6. So it's just showing with those multiplication tables that I am adding 6 each time. So if you notice right here, I'm starting with a negative number times a positive number, and I'm ending up with a negative 12. Then because I'm adding a factor of 6 each time, when I get to right here, and I have negative 6 times negative 1, I'm now ending up with a positive 6 because I added a factor of 6 to negative 6 times 0. So kind of neat to think about there as you're kind of looking and exploring those rules. With multiplying integers, the rules are that if it's two signs, your integers, the two integers have the same sign, then your answer will be positive. If your integers have different signs, your answer will be negative. Now, it's very important to remember that these rules only apply to two integers being multiplied at once. So again, notice these rules. A positive number times a positive number is always a positive number. That's just how you learned your multiplication facts. A positive times a negative, so a sign of each, will give you a negative answer. A negative times a positive, negative answer. And then a negative times a negative will give you a positive answer. So let's look at a couple practice problems. So, first, we're just going to multiply like normal. 3 times 2. Right here, this example 1. 3 times 2. What is 3 times 2? Well, I hope you said 6. And then look back at our rules. What is a negative times a positive? Well, a negative times a positive gives me a negative answer. So negative 3 times 2 equals negative 6. Let's look at another example. Negative 2 times negative 4. I'm going to start by just multiplying the absolute values. So 2 times 4 is 8. Let's go back and look at our rules again for a second. What is a negative number times a negative number? Well, I hope you said positive. So negative 2 times negative 4 is just positive 8. So for multiplying integers, you're going to multiply the absolute values like normal. And then, if your signs are the same, your answer will be positive. If your signs are different, your answer will be negative. So let's take a look at activity 3. For activity 3, you need to be able to answer these two questions. What are the rules for multiplying integers? And make sure, always ask yourself at the end, did I check my sign? Good luck on activity 3. All right, boys and girls, let's start activity 4, which is applying integer operations. So really the only thing for this part that we need to remember is the property of operations. And you are probably already familiar with those. And we're going to review real quick the order of operations. So remember, the order of operations are the rules that state the sequence, okay, the rules that state the order in that you would apply operations to an expression. So let's look at an example. So here are our order of operations. Okay, you have probably seen these throughout your years in school. First, we're going to clear any grouping symbols. That's your parentheses, your brackets, things like that. Then we're going to see if we have any exponents to take care of. Next, we're going to multiply or divide left to right, whichever one comes first. And then last, we're going to add or subtract left to right, again, whichever comes first. So if you'll look at this problem on the side with me, I'm going to work through it. I'm going to show you kind of my step-by-step and how I organize. So I'm looking through this and see if I have any parentheses that is grouping a problem together. And I don't have any groupings. Those parentheses are just separating numbers. So I'm going to go next to exponents. I have no exponents. Now I'm going to look for multiplication or division and work through the problem left or right. So first, I'm going to do -5 times 6. And if you recall from activity 3, I'm just going to multiply 5 times 6, which is 30. And then does anyone remember if I have a negative times a positive, what my answer will be? Will it be negative or positive? I hope you said negative. Then I'm going to rewrite the rest of the problem. So -30 plus 3 plus -20 divided by 4 plus 12. Now I'm looking again, do I have any more multiplication or division? Yes, I have division. -20 divided by 4. Now, division of integers is almost identical to multiplication. You're going to divide 20 divided by 4, which is 5. And then the rules are the exact same. What is a negative divided by a positive? Well, it's going to be -5. So I'm going to rewrite the rest of the problem. -30 plus 3 plus, let me fix that. Positive 3 plus -5 plus 12. Okay, so I don't have any more multiplying or dividing. So now I'm just going to add or subtract straight through the problem. So -30 plus 3. We got to think way back to activity 1. Are my signs the same? No. So I'm going to subtract. 30 minus 3 is 27. Take the sign of the greater absolute value, which would be negative. Then I've got plus -5 plus 12. Now I've got -27 plus -5. My signs are the same, so I'm just going to add those two together. And I'm going to get -32. Now remember, it is negative because both signs are negative, so I'm going to keep that same sign. And then last but not least, I've got to add 12 to -32. Are my signs the same or different? They are different. So I'm going to subtract 32 minus 12 is 20. And then because my greater absolute value is negative, I'm going to keep that negative sign. So my final answer here would be -20. Now, a few tips I have for you is to go back, make sure you review all of these order of operations, the step-by-step that you will do these in. And then notice how when I was showing my work, I rewrote each level so that I didn't get lost in the numbers and where they were. So as you begin activity 4, some guiding questions for you. Do you know the order of operations? Your grouping symbols, exponents, multiply or divide left to right, add or subtract left to right. And then make sure you're paying attention as to which part of the problem you need to solve first and then which one's coming next. Good luck on activity 4.